All right, so today we're talking about all of these different twists that are going to show up in Advent of Tess. So we're going to go through how to fold each one, looking for what references do we need to fold each one, and then we'll go through how to recognize each twist in a finished tessellation. So this is really helpful for reverse engineering things that you see photos of. And we'll also go through how to recognize the twist in the crease patterns of those same tessellations. So let's start off with what each of these twists are, and then we'll go through how to fold each one. So I've got two sizes of triangle, two sizes of hexagon, two sizes of rhombus, and one size of trapezoid. And you'll notice that each of these shapes, the way that I've folded them here, is in the same shape that I named it as. So we have the pleats leaving these outer shapes perpendicular to the boundary, which means that if I had a mirror image of this, it would be able to connect and line up. So this is illustrating the tile of each of these twists. And a tile is an abstraction of basically how pleats are moving between twists, between these pleat interactions, that allows us to construct patterns without choosing specifically what twist will be in a location. So we've got triangle things and hexagon things and rhombus things and trapezoid things, and those correspond to the directions the pleats are going, but it doesn't necessarily tell us whether there's a closed or open hole on the back. And so we'll see the closed and open holes on the back in the triangles, the hexagons, and the rhombi, although with the rhombus it's more of a slit for the smaller one. And then with the trapezoid, I actually call this an open trapezoid, even though it has the slit, because there is a more closed version that comes around a single point. So these are the options that we'll be working with, the different twists. And welcome early, welcome everyone watching. And now I'm going to grab some grids. I've got some triangle grids on hexagons. We'll use 7 of them, and I have 8 divisions in each grid direction here. So what we're going to do is work through exactly in that order that I introduced them. So first, closed triangle. And for a closed triangle, we're thinking, okay, I've got these 3 mountain folds that are making a 3-way intersection. It's rotationally symmetric. So I have 3 equally spaced directions. And if I bring those up as mountains, this is the classic 3-way intersection that if we were not twisting, we could lay down flat. We could lay down flat in another way. But if we want to have a twist, then we need to have all of those pleats laying down rotationally the same way around the center. Now, whether that is right-handed like this one, or left-handed, like so, is kind of arbitrary. That is to say, it's arbitrary when you're folding a single twist. It is not arbitrary when you're folding in a broader pattern. But for today's purposes, I'll do right-handed demonstrations, and we will squash. So you'll notice when we squash, we are creating new folds in the paper, specifically along these mountain folds in here, and we're erasing the mountain folds that we used to set up the twist. Also, the valley folds are coming exactly to the corners of this new shape, this central polygon of the twist. And that is a pattern we'll see over and over. The valleys always come to the corners of the twist. Granted, you might be saying, well, the mountains are also coming to the corners, but the mountain and the valley that are parallel come to opposite ends of a side of the twist. So that's the closed triangle twist. Now let's take a look, and by the way, if we have this twist centered, the mountain folds are going to go to every other corner of the hexagon. So next up, let's do an open triangle twist. Here, I'm going to have 3 grid directions of mountains again, but the difference this time is that they're not going to all come to a single point. They're going to outline a grid triangle, a single grid triangle. And another difference this time is that we cannot arbitrarily choose which direction, right or left-handed, to twist this arrangement of mountains. There are very different conditions if we want to twist it the other direction for getting it to lay flat. And actually you can see all about that in my cursed twists video. So as you might guess from the name, that's rather more difficult and involves pre-creasing. So here, again, our valleys are 1 spacing away from the parallel mountain, and we'll bring up our mountains. Make sure to fully fold our valleys further out. And granted, we're not getting them fully down quite yet, but we're making sure that our valleys are definitely on grid lines. And we can press where those valleys run into the next direction of mountains and just outside that, and then press from the top to complete the open triangle twist. So we have closed coming to a closed point because those projections of mountains into the center came to a single point. We have open with an open hole in the middle, 1 grid spacing per side triangle, because those projections of mountains came around an open hole in the center. And once again, these mountains that we project into the inside of the twist, they go away when we actually squash. So these are our 2 triangle twists. Next up, we have the hexagons. So folding a closed hexagon on a hexagonal grid, or I should say edge parallel hexagon grid is, okay, I'm not going to call it straightforward, but what I will say is you do have good references. All 6 grid directions that go from corner to center are going to be mountain folds. What I'm going to do is build up 1 set of mountain and valley at a time as I'm working my way around the center. And I was careful to do this up off of the desk only because with 8 divisions, it's actually easier to fold this in the air and then take this tower that's sitting on top and make sure that it spins around. So if I was doing this with more grid, I would be keeping things flat on the table and holding down those pleats that I'm putting in 1 at a time further out from the center and getting a bit of a tower and then shunk, squashing it down from there. So all 6 of my mountain folds came into a central point, and correspondingly we have a closed point on the back. So this is our first twist and only twist for today that does not create any new folds when you fold it on the grid. Next up, we have the open hexagon. So where the closed hexagon had the mountains going straight to the corners, the open hexagon is going to have the mountains 1 spacing higher. And so on each direction, we can take note of that. And just like the open triangle twist, we do have a fixed rotational sense once we've chosen the mountains. Those valleys are going to be 1 spacing further out. If you put the valleys closer in, then you're just going to get a closed hexagon twist on the backside. So what we're aiming for with this open hexagon twist setup is a puffy star shape in the center. And with this puffy star, this is the easiest twist to collapse because you've just got to keep your plate stable and then you go pop from the top. And you can, of course, do it more gently, but bopping from the top is really the easiest way to get things in place and prevent pleats from wiggling out as you're trying to hold all 6 of them in place at the same time, and also get the twist flat. So if I draw these projections of mountains a little bit further inside of this hexagon, you can see that I'm outlining a hexagon with 1 grid spacing on each side. And that is precisely the hole that we see on the back. So after this, we actually have a twist that combines a couple features of 2 different twists. So the rhombus is basically, the closed rhombus is basically a combination of features of the open hexagon and the closed triangle. So how does that work? Well, if you take, and I'll draw with a different color, if you take this corner of the open hexagon, that is precisely half of the closed rhombus, and actually functionally this other corner over here is the other half. But you can also say, so pretend that those 2 have come together. You can also say that the closed rhombus is made up of 2 of these closed triangle twists. And the fact that this is how these twists are like the rhombus twist has properties of both of these 2 twists actually does come up in how we go about folding it in broader tessellations, but mostly at further repeats away from the center than we'll be seeing in Advent of Tess. So how do I fold this strange fusion twist? Well, we're going to have mountains coming in straight from one side and the opposite side, but then we're also going to have mountains that are offset in another direction. And so we have this interesting feature where if you look at the pleats from the bottom and this right-hand side, it looks like those are two pleats that belong to the open hexagon. Just look at the angle that those two are meeting. It's exactly this angle. But on the opposite hand, and so that's this pair and this pair. But on the other hand, we have this pair and this pair that are coming together exactly like the closed triangle. So we've got that more obtuse angle, the 120 degrees. And so now, similarly to the open hexagon, we have our valley folds that are fixed in place. And it's the same orientations of the valley folds that we would expect given these two pleats from the open hexagon. And then we're going to have rotational symmetry with the rest of the pleats. So we're bringing this up, and instead of a full puffy star, we have 2 points of a puffy star and no space between. So look at these blue outlines in the open hexagon. That is precisely what would happen if we took these two corners and took out the middle and just mushed them together. Precisely the same outcome. So we can get our twist set up, and then like the open hexagon, we're going to squash from the top. Now, we've seen two different open twists so far. We've seen the open triangle and the open hexagon. And with the open triangle, what we did is we had two of the pleats staying in place and the third one shifting over functionally, because if this was over here, it would make the closed triangle, but since we moved it, it makes the open triangle. And with the hexagon, we moved all 6 pleats away from the center. So the difference between the closed rhombus and the open rhombus is kind of halfway between those two. We're going to have 2 pleats that stay in place. I'm going to open this up so I can see exactly what I'm doing here. So I'm going to pick 2 pleats that stay in place, and then the other 2 are going to shift around. They're going to shift around in the same sense that the twist is twisting. So the one that was going to be right here is going to shift over to the right, and the one that was going to be right here is going to shift down. And so now the shape that is outlined is this 2x1 parallelogram. And the shape that we're going to see when we bring up the pleats is these little puffy stars outside, or puffy star corners outside of the outlined shape. And I like to call this an anvil shape. So I'm bringing up my 4 mountain folds, and we have the same orientation of those valleys as before. And so I'm finding that anvil where I have one direction 2 spacings apart and the other direction 1 spacing apart. And setting this up, and again, it's a little bit easier if I have more grid, and starting to squash kind of from the top, but also, especially on these pointy corners, holding down where that corner is going to be to make sure that my folds make it all the way out there. So we end up where with the closed rhombus, it was functionally two closed triangles. The open rhombus is functionally two open triangles. So you can see that the bottom half here is identical to this open triangle in my left hand. So, and to make that a little bit clearer, I can sketch in so we can see, actually I'll do this with the other color, we can see these open triangle setups inside of the open rhombus. So that's pretty cool. And this is almost all of the twists. It's all of the twists that were used in last year's Advent of Tess, the 2022 version. And this year we're adding one more. So this year we have the trapezoid twist that I'm adding. And what I want to do is first set up an open hexagon puffy star. Because we're going to use a lot of the same pleats. And so with an open hexagon puffy star, I'm going to start disappearing some of those pleats. And really, I'm going to be cutting down the middle. So what I've got here, I have 3 pleats that I'm going to keep. And I'm going to be cutting down the middle of the puffy star. And this will be really clear in the Advent of Tess tutorials as well. We're specifically going to do a pattern that has a start and then finishes it with hexagons. And the next day have the same start and finish it with trapezoids. So we're going to be cutting through the middle of our hexagon because a trapezoid is, after all, half of a hexagon. And erasing. This pleat also shifts. So I had a mountain here for the puffy star. I'm actually going to get a new mountain going down this way. And then I can squash my new twist. So there's a couple ways to think about this trapezoid. You can see it as half of the open hexagon. So if I get that one squashed, this is half of that open hexagon. We can also see it as the closed rhombus plus another triangle. So if I mush these together, that's another way to conceptualize it. What I like to think about is generally the it's half of an open hexagon argument. And one thing to notice here is that the central mountain fold of those 3 pleats that would have belonged to an open hexagon is the one that continues out the other side in, and this is the first time that we've seen this today, we have a pleat that is more than 1 grid spacing wide. So I call this a double depth pleat because it's 2 grid spacings where all of the others are 1 grid spacing. And we're able to get that squashed and in place all without pre-creasing. So that is the folding portion for today. And I'm seeing some wonderful comments in the chat. Edith, I'm glad that you like these explanations. And bienvenido. And now we're going to look at, okay, we've found all of these twists. Let's work at recognizing them in finished tessellations. And again, this will help with reverse engineering things later on. For Advent of Tess, everything is fully taught, but the further out repeats, you're going to need to recognize either from the crease pattern or from a photo of the folded state, what goes where and how they're connected. So with this particular tessellation, we have we have one twist that's easy to recognize, and that's this central twist, this closed hexagon. And the giveaway with the closed hexagon is, first, it's a hexagon, and second, all of its edges are on grid lines. So that's dead giveaway for the closed hexagon. Then in here, we have these shapes that have some fat corners and some skinny corners. So what I'm going to do is peel back a layer and reveal we actually do have that closed rhombus in there. And so we're able to see, okay, we have a closed hexagon. The next twist are closed rhombuses all the way around the hexagon, 6 of them. And we're also able to see the skinny corner is the one that connects to the hexagon. So far, so good. Then this hole, that doesn't look like any of the twists that we've seen. Why does it not look like any of those? Because we saw all of the ones that are used in these tessellations that I'm going to show you. Well, maybe it's because this rhombus is so close, it's stealing paper away from the hole. And that's exactly what's happening in this case. So if I flip over, it still doesn't really look like twists that we know, but we can see there are 2 pointy corners next to each other. The only twists where there are 2 pointy corners next to each other are triangles. And in this particular case, if we zoom in here, we can see that the mountains going in from those corners are outlining a grid triangle. They're not all coming to the same point. And so this is telling us this is an open triangle twist. And we can see that third corner tucked away inside. And it's tucked away inside because of this super dense spacing. And I would apologize for the super dense spacing, but if I didn't use super dense spacing by the middle of Advent of Tess, we would be needing to either fold partial twists or to use 24 fold grids. So that's what's going on with the dense spacing towards the end. And so in this tessellation, we have a closed hexagon with closed rhombus twists connected to the skinny corner. And if you remember, the skinny corner is the mountain that goes all the way through of that closed rhombus. So seeing these details is how you're going to be able to find your pleats and fold repeats of patterns that you've only seen photos of. And then we don't really have to worry about the spacing of the open triangle, because that's going to be a consequence of the spacing of the rhombuses around this hexagon. And if we can see, okay, the skinny corner of the rhombus is one spacing from the corner of the hexagon, then that's going to set the spacing moving forward. And then we would really have a choice here between a closed triangle or an open triangle, but that's something I'll get into more in the folding tutorials. So next up, we have a tessellation that uses the exact same structure, but the opposite twists. It uses a open hexagon twist. So here we have a hexagon, and its edges are not on grid lines. Specifically, they are perpendicular to grid lines. And that's a giveaway for the open hexagon. And then here we again have these shapes with some pointy corners and some fat corners. That's going to be a rhombus. And which rhombus? Well, the edges here are like in one, out two, in one, out two, which is characteristic of our open rhombus twist. And it's in one and out two on this one, and in two and out one in our demo, because this demo is folded right-handed, and these twists are left-handed. So from here, we can then look to there being something else going on here. There's something going on at that point that is not just the rhombus twists. There's actually 3 pleats going into that closed point. And I can say already, 3 pleats going into a closed point. That's going to be a closed triangle twist. And flipping over, that's exactly what we see here on the back side. So one of the key problems that I see with people trying to identify twists in tessellations is that they fixate a lot on whether their demo piece is the same size as what they're trying to identify. But the more important feature is how the folds are oriented with respect to the grid. Are they exactly diagonal to the grid, like the closed triangle, or are they at a different angle, like the open triangle? Are the projections of the mountains outlining a grid triangle, or are they all coming to a single point? And then, so that covered our closed and open hexagon, rhombus, and triangle. Last but not least, we have a tessellation with trapezoid twists. And so here we have twists that have both pointy and fat corners. They have 2 of each kind of corner, but each corner is kind of paired with the same kind. These aren't alternating skinny and fat corners like the rhombuses. And also, these twists have one edge that's twice as long as the other 3 edges. So all of those features point to trapezoid. And then what is this strange gap in the back? That kind of sort of matches the corner of the open hexagon hole. So we can see it's about this much of the open hexagon hole right there. And if I hold on to that on both sides and flip, we can see that's actually another trapezoid, and we have the same hole on the other side. So all 3 of these tessellations that I'm showing and demonstrating today are tessellations that we will see the starts of in Advent of Tess. And now it's time to take a look at the crease patterns for these 3 in the extended forms, which is more than we'll see in Advent of Tess. So for the crease patterns, what you're going to be looking for to identify twists are those central polygon shapes. So you'll see them either in mountain or in valley form. And there's other areas of the crease pattern that might confuse you, that might look like twists. Like this bit that looks like a very weird triangle, because none of our triangle twists have edges on the grid lines. So this really looks like a triangle twist, but it's actually a space between things. It just doesn't have the typical mountain-valley alternation that we see in other spaces between things. And by the way, in here as well, because the corner of this open triangle is touching the corner of the closed rhombus. So if those two had any space between them, the fold between those two corners would be a valley. And that would interrupt the mountain triangle that we have here that's not actually twisting. So we've got our central hexagon, and like we saw in the folded form, we've got the skinny corner of the rhombus, one spacing away from the corner of the hexagon. And then where the pleats from two neighboring rhombuses come together, we're going to have this open triangle twist on the back. So when we're looking at crease patterns, if we see our central polygon in red, those are mountain folds, that will be on the front. If we see the central polygon in blue, those are valley folds, the twist will be on the back. And then our next tessellation, we see that open hexagon with our folds for the central polygon of the open hexagon going perpendicular to grid lines. So that's our dead giveaway here. And then with our rhombus, again, the in one, out two, in one, out two, in one, out two. This is distinct from the in one, out one that we would see for a closed rhombus. And so we know that this is an open rhombus. We can also take the mountain folds that are coming into the corners and mentally project them into the twist, in which case we end up outlining that 2x1 parallelogram. Whereas for the closed rhombus, if we projected those mountains in, we would end up outlining this little slit. So those are two ways that you can distinguish between the closed and the open rhombus twist. And from there, we're looking at closed triangle twist on the back, again, with those edges perpendicular to the grid lines. Or I should say perpendicular to the grid lines that they're crossing. So that will be true of the closed triangle, closed rhombus, open hexagon, and open trapezoid, that the grid lines will be perpendicular to the fold lines of the central polygon. And then, last but not least, we have our trapezoids. And here we actually get to see triangle twists on both sides of the paper in the same tessellation. So when we're starting this tessellation, the center is in the middle of this loop of 6 triangle twists. That central hexagon is not a twist because the edges are alternating mountain, valley, mountain, valley, mountain, valley. Granted, if it was just doing that and then had pleats and didn't have any of these off-grid lines, that would be an iso-area closed hexagon twist, and I have a different video all about those. But since we have these 6 triangles, that central area is completely explained by those triangles. And so we're able to say, okay, closed triangle on the front, closed triangle on the back, closed triangle on the front, closed triangle on the back. And then connecting, we have these trapezoid shapes that are paired in front-back pairs. So you'll always see this open trapezoid on the front right next to the open trapezoid on the back, which can make it a little bit hard to see that this mountain fold and the valley fold on the opposite side of these long edges are actually 2 grid spacings apart. So it can be a little bit hard to see all of the pleat references in a full tessellation setting. And that's why I rely heavily on the central polygon, because that is not going to change in really any of the crease patterns, at least the ones that I use. So that's how we're looking at all of these different twists and finding them in physical, in already folded tessellations and in crease patterns. And yes, earlier you were definitely right. Those creases are very tight together. One thing that can be done with the Advent of Tess pieces, if you don't want to go for that super high density, is fold 24 fold grids instead of 16, and then space everything 1 spacing further apart. And with the twists used this year, that is a valid option for all of the different challenges, or all the days of the broader challenge. So one last thing that I want to bring up today is that I go more in depth on most of these twists. So not the open rhombus and not the trapezoid, but the rest of them. And also the closed and open square and the closed right triangle in my course called Basic Twist Bootcamp. So actually I'll grab those other 3 twists that I just mentioned. So closed and open square and closed right triangle. I have a lot of demos within arm's reach. And in Basic Twist Bootcamp, I go over what we went over today, but also how can we practice right and left-handed forms of each of these twists in a broader tessellation that's specifically aimed at a beginner level, and trying to help you see, and I go into more depth and detail on exactly the crease pattern of each of these, how that relates to folding, how you can transform from right to left-handed forms, and seeing that crease pattern on the front and back, right and left-handed. So it's a great reference for really diving deep into understanding these twists. And several of my students have commented that it's a really great resource to go through before doing the denser spacing, before doing the different arrangements that you see in Advent of Tess. So I'll leave you with that. Happy folding. Next week is Thanksgiving here in the US, so I will not be doing a YouTube live stream, but I will be doing a preview of the first lesson of Advent of Tess over on Instagram with my friend Mariela of Origami Maniacs. So happy folding, everyone, and keep an eye on your emails if you're on my email list for details of how to see next week's stream. So happy folding.